Hello fellow hams, this is Yankee Oscar 3 Hotel Echo X-Ray with the promised video about G90, about XIEGU G90, which I'm the proud owner. This is my unit, so I'm not going to criticize in any way this very nice transceiver, which offers a lot for money. Just wanted to make some measurements in terms of spectral purity. Not going to make any consideration in any discussions in any way about FCC compliancy and my local ANCOM compliancy, because it's quite clear that it does make those compliancy. What I wanted to see is what is the spectral purity from my unit, because it believe it or not, it differs, and also what is the actual output power that is going to put out. So here we are having a dummy load. It's 250 watts dummy load. Here we are having a sampler. It's an HF sampler, 50 dB. In fact, the measured deviation from 50 dB is 50.11 that we are going to take into consideration. This is the output here, directly connected to the output. So we have the transceiver, we have the output, we have the sampler, we have the dummy load. The cables are RG402, which it's more than enough for this application anyhow, but those are my patches around. So from the sampler, I don't know if you can see it, but I'm going up into my spectrum analyzer, which is a Siglent SSA 3021X Plus, and the cable is going into attenuator of 30 dB, and then into the spectrum analyzer. Now, this particular attenuator is good up to 18 gigahertz, so again, not a problem there. The actual measured attenuation for this particular attenuator is 30.03 dB, which is more than precise. So everything will be taken into consideration, and I'm going to set up the spectrum analyzer, and I'm going to transmit using CW at the beginning of each main band. That would be 160, 80, 40, 20, 15, and 10 meter bands, ham radio bands. I'm going to, each of those will be at the beginning of the band. That is 1.8 megahertz, 3.5 megahertz, 7 megahertz, 14 megahertz, 21 megahertz, and 28 megahertz. So that is the setup. This is what I'm measuring today. Those are the premises of the measurement. So I'm going to set up the spectrum analyzer. I'm doing it quickly from the buttons. So I'm going to. Let's go with the preset first of all. Okay, so let's start frequency 1 megahertz, and the stop frequency would be 30 megahertz. Okay, that is that. I'm going to go to amplitude. I'm going to turn off the attenuator. Okay, we are having a reference level of 20 dB, minus 20 dBm, sorry, and the noise floor is at minus 90. The bandwidth, that is going to be around, let's say, something that will not put us in a lot of weight, 3 kilohertz. It seems like, let's put it 1 kilohertz. Okay. And VBW of around, let's say, 300 hertz, which would give us a noise floor right now at around minus 110. Okay, Let's see again at the amplitude, everything is good. Now, because we would like to see also the actual power, I'm going to set up a read offset. Remember, I said that we are having 50.11 and 30.0205. Okay, so we are having, I'm going to consider it that we are going to have 80.11 dB read offset from this one. The reason for which we're doing that is that I would like to see the actual value of the measurement and not only a relative value from the fundamental frequency to F2, F3, and so on and so forth. So right now, let me see, we are at 1.8 megahertz. So I'm going to send the carrier, and we are going to, for a peak, that would put us at 42.28 dBm. Let's add a marker here. Okay, and let's go, because it would be, sorry, normal. It would be almost impossible to detect. Let's go at, oh, oopsie daisy. Okay, so we are having the third harmonic at 5.408. Now, if we are going to go back to the marker number 1, and we are going to say marker function, and we are going for the frequency counter, you are going to see that the frequency is spot on, nothing to comment here, 1.800001 megahertz. So we are having a deviation of 1.02 hertz from the actual readout, which is very good. Now, if we are going to create another marker, let's say select marker, let's say marker 3, okay, which is here, and let's say a delta, relative to marker 1, and we are standing at about 47 dBc actually from the carrier. Okay, so it's good. I do think that it complies with the FCC. I don't have deep knowledge because I'm in Romania. My actual laws are a little bit different as far as I know, but I do remember that I read something below 45. Maybe I'm wrong, okay, but I do think that we are well under the FCC regulation, which is 47.9-ish. That is for the 1.8 megahertz band, that is 160 meter band. If we are going down to, to 3.5, let's go with marker 1, and let's put it, because we are going to 3.5 megahertz, and let's say marker 2 is going to be off and marker 3 is going to be off, and let's put out a signal there. So we are having 42.67 dBm, and if we are going with another marker, let's say marker 2, but normal, and we are going at, sorry, okay, we are at 10.512, which is, again, if my calculus is right, is the third harmonic, and we are standing at around 14-ish. Let's say another marker and get the number right. We have a delta relative to 1, which is correct. We are standing at minus 56, 57 dBc, which is, again, an excellent performance in my opinion. So that is one thing. It's beautiful. So if we are going to consider, let's make this calculus now. If we are going to consider 42.67 dBm, 42.67 dBm, 2 watts, would give us around 18.5 watts, which again, in my opinion, for a 20-watt transceiver, it's very good performance. It's actually stellar. As I said, I didn't have no doubts regarding its performance. Let's go with the marker 1 normal at 7 megahertz. Okay, and marker 2, let's say it off. Marker 3, let's say it off for now. And for marker 1, we're going to put a carrier. Sorry, my bad. Okay, so that is 7 megahertz. So let's put the carrier on. Wait for it. Yeah, and that's because it was not the right mode selected. Okay, now it's CW. Well, things happen. Okay, so we are 42.77 dBm, which is a little bit on the high side, and as you can see, there is no spurious emissions in F2 or F3 whatsoever, so this is well above the noise floor, which is great. So I cannot measure it. Probably if I would go down with the preamp, I could see a spurious emission there, but an F2 or an F3, but it's not the case. If we are going to the 14 megahertz band, and we are going to say marker 1 at 14 megahertz, we are going to see that we are having a dashing 14 megahertz. The deviation from the actual 14 megahertz is 7.59-ish hertz, which is very nice. And again, there is no spurious emission as far as I could see, which again is great in my opinion. Probably somewhere under the noise floor that is right now, I could see something if I would start the preamp or if I would go down with the noise floor. Please keep in mind that this is the real noise floor that we see around minus 110, so this is just a reference because we referenced here with a reference offset of 80.11 dB, so I would say we are quite good. Now let's see on the 21 or the 15 meter band, let's go with marker 21 megahertz, which would give us 43.05 dBm. If we are going to calculate it again, 43 dots, let's be precise, 0.5 dBm, it will give us around 20 watts, a little bit over, I would say, so it's very nice. We are having a beautiful 20 watts here in the 15 meter band. Now on the 10 meter band, CW, okay, let's go up to 28 megahertz. Let's start it. Okay, so we are having a 43.32-ish dBm, 43.32. So that would give us a little bit over 21 watts on 28 megahertz, which is stellar. And again, of course, the spurious emission from the 28 megahertz band, from the 10 meter band, would be way outside the HF band, and I do think that it's well suppressed and within parameters. So the only actual where we could see something in the spurious emission in the F2, F3 type of actually F3 frequency would be in the 1.8 in the 160 meter band. Yeah. Which from my point of view is a very nice job, and the performance is it's quite well. We are having 42.27, and if we are going to calculate here 42.27, sorry, it will give us 16.80, so 17 watts, which is well within the boundaries of the advertised performance. Okay, so 7 megahertz. If we are going to normal 7 megahertz here, and we are going to measure here, again, we do not have any spurious emissions here. I will go down because let's see if we can go with the amplitude. If we're going with the preamp, if we can see something here. So it's I don't think that all those spikes here are actual. Let's see, because we are over reference, so let's see if we can go down. We cannot actually, but I do think that those spuri that we are seeing, let's see the marker 2, and let's see where those spurious emissions are. So we have one here, which is at 40 megahertz, which is perfectly normal, and 21 probably, yes, 20.99 and 28 megahertz. Right? But are well within buried in the noise floor, because remember we have the preamp started. Now those spuri from here, which I do think that those are from the mixer, because we are having a little bit of a level here. I could add another attenuator here, and I could get rid of those, but at this particular moment it doesn't really matter. So if we are going to make this one a delta relative to 1, we are 54-ish dB under the fundamental frequency, so we are minus 54 dBc. All in all, if you are asking me, it's a very nice performance from XIEGU G90 and is well within the boundaries that were advertised for this particular transceiver. A very nice transceiver with a lot of capabilities, and for the money paid, well, you get a lot of options. My opinion is that if you can find one, buy it. I know there are a lot of fans of this one. I know that there are a lot of people that are using it. I'm still using it in portable operations, and I did have a lot of fun with it. The fan factor is beautiful. So, hope you enjoyed it. This is Yankee Oscar 3 Hotel Echo X-Ray. Please post your comments. I would gladly answer those comments if I know, of course. And if you find it interesting, please don't hesitate to drop me a line. Cheers guys, 73 from Yankee Oscar 3 Hotel Echo X-Ray. See you on the bands.